Hello and welcome everyone. We are live right now. I hope I'm audible to all of you. All right. So welcome back to this amazing platform Tutee Learning. So today, we're going to discuss about the parabolas, like as we were discussing in our last class. But today we are going to discuss about the general equation of parabola, right? So as I promised that, how am I going to decide that whether from a general equation of a conic section, how to know that whether this particular conic section is a parabola or a circle? Like we have discussed about circle, right? But what about ellipse? What about hyperbola, right? So all those non-degenerate conics, today we're going to discuss about that from the very basic principle, right? Or how to derive the general equation of a parabola, right? So that is what we're going to do in today's class, right? So I hope you are all ready to start with it. And again, another important request to all of you that if you haven't watched the previous lectures, please go back and watch the previous lecture, okay? So all those so that you are able to understand whatever things are going on in this particular lecture, right? So today, let us start with our current discussion that will be on general equation of parabola. Okay, so let us discuss about the general equation of a parabola. Okay, so in today's lecture, we're going to discuss about the general equation of parabola, and we have already done this particular thing when we were discussing about how to write the general locus equation of any point with respect to any conic section, right? So in order to do so, we will again define the same set of quantities, that is, let the focus be given as some arbitrary point a comma b. Okay, so this is be the focus. And let us say the directrix is given as Lx plus My plus N is equal to 0 is the directrix. Okay, is the directrix. So let us say this is the directrix equation and we have this particular condition with us, right? Now we have already discussed that in case of parabola, the eccentricity is equals to 1. So in case of parabola, the eccentricity is equals to 1. Therefore, if I draw the coordinate axis, and then if I try to represent the parabola, let us say it is any arbitrary parabola like this, such that the axis is something like this, where I have the focus which is given as a comma b, and the directrix is given something like this, right? So it is perpendicular to the directrix. Axis is perpendicular to the directrix, and this particular equation is given as Lx plus My is equal plus N is equal to 0, right? And let us denote some of the points. Let us say this is Z, and if we take up any point on this parabola, let us say that is P, and that distance, the perpendicular distance of point P from the directrix and the distance of point P from the focus, that is S, so PM is equals to PS. So that is the very basic definition from the conic section having the eccentricity equals to 1, right? So if I take up any point P whose coordinate is given as x comma y, in this manner we can easily represent the equation of a parabola as PS is equals to PM, right? So if you do that, you will be easily able to get to the equation of the parabola, right? So if I do few lines of calculation, so you will get x minus a whole square plus y minus b whole square is equals to Lx plus my plus n divided by L square plus m square, and the square of the numerator, right? Alright, so this is how you're going to obtain the simple equation of the parabola. Okay, so this is how you will obtain the simple equation of the parabola. So if you solve this part out, you will see that you will be obtaining some equation, something of the form. So if you simplify it further, you will obtain some equation of the form mx minus ly whole square of it plus 2gx plus 2fy plus some constant is equal to 0, right? This is how the general equation of parabola look like. Okay, so this is the general equation of parabola, you will obtain some equation of the form which you can easily do it by solving few lines of algebra over here, right? So what you observe is that we have both x square, y square and xy term with us as well, right? The second degree terms in the general equation of parabola actually forms a perfect square. So what you can also observe is that the second degree term, that is x square, y square or xy, they actually forms a perfect square, right? So that's why I've clubbed it as perfect square, right? So this is a very important observation that we have in case of parabola, is that the second degree term forms a perfect square, right? So this is how to understand that whether you are having the equation of a parabola or not, right? Now let us say you have no clue about how to solve about from the general equation of conics, and you still want to understand what this particular equation actually represent, right? So if you are having the general conics equation, first of all you have to calculate the delta matrix, okay? So and then calculate determinant of that delta matrix, so which is delta should not be equal to 0. That is a condition for the non-degenerate conics, right? Now along with that, since it is a parabola, we will have the condition that is h square minus of ab, h square minus of ab should be equals to 0. H square minus of ab should be equals to 0. That basically means the second degree term, second degree terms form a perfect square. The second degree term form a perfect square, okay? So this is a basic understanding that we have from here. The second degree term will form a perfect square, therefore h square minus ab has to be 0. Alright, so this is the condition for parabola, right? Now in the similar manner, if I want to know for any general conics what is the condition, so from the second degree curve equation, the second degree term will form a perfect square, therefore h square minus ab has to be 0. Alright. Okay, so this is my general second degree conics equation for parabola, right? Now from this, the very first condition to know whether it is a degenerate or non-degenerate conics, you have to check for delta. The delta is defined as the determinant of this particular matrix, okay, which is a symmetric matrix as over here, right? So this particular thing is not equal to 0. That basically means we are basically discussing about non-degenerate conics. First condition to know whether it is a degenerate or non-degenerate conics, you have to check for alright. So this is the condition for non-degenerate conics, right? Now from here also we have to check following the conditions over here. That is, if I have a equals to b and my h is equal to 0, then this is the condition for circle, right? This is what we have discussed in our previous lectures, right? In the circle lectures, right? Now along with that, if I have h square minus ab equals to 0, then this is a condition for parabola. This is the condition for parabola, and similarly if I have h square minus ab to be less than 0, then this is the condition for hyperbola. This is what we have discussed in our previous lectures, right? In the circle lectures, right? Okay, this is a condition for hyperbola, and similarly if my h square minus ab is greater than 0, then this is the condition for ellipse. This is the condition for parabola. Okay, now these are the all some sort of things that you need to keep in mind. And in this hyperbola case, if I have another special case is that if I have along with this h square minus ab negative and a plus b equals to 0, then this is the case of rectangular hyperbola. Then this is the condition for ellipse. Okay, rectangular hyperbola. Now these are the all, I hope this is clear to all of you. Okay, so in this case, these are the ways to denote or to know whether what type of conics you actually obtain, okay, in the non-degenerate conics, right? So this is the easiest way to understand the things, right? Now if you want to know that how this particular expression h square minus ab comes into play, is very simple, that when we go into the different chapter, like for example in case of parabola, what to be observed is that the second degree term should be a perfect square. So therefore from this general equation of conics, in order to be the second degree term, that is this particular term, that is this particular terms to be a perfect square, therefore we should have h square minus ab equals to 0. right? In a similar manner, in case of an ellipse, we will see that different modification will make a different result, which is related to the eccentricity, right? So in case of ellipse, the eccentricity is less than 1. In case of hyperbola, the eccentricity is greater than 1. So depending upon the condition of eccentricity, we can easily obtain this particular criteria, right? That is h square minus ab is equals to 0 for parabola, is negative for hyperbola, is positive for an ellipse, right? So these are all the three important discussion that we need to keep in mind in order to discuss about the or recognize the general conic equation. I hope this is clear to all of you. So in regard to this, let us try to solve one problem over here. Alright, so if I say that I have a given conic equation, so let us say we have a general conic equation which is something like this. Now in the question it is asking you to find out the value of this unknown lambda such that, so to find out the value of the unknown lambda such that this particular equation is actually representing a parabola, right? So this is a simple question. The first and foremost check you have to do over here is that you have to check whether it is a non-degenerate conic or not. So in order to do that, you have to find out that determinant delta should not be equal to 0. That is the first check. And secondly, for parabola, you have to equate the condition, that is h square minus ab should be equals to 0. So these are the conditions which represents a parabola. So this is a simple question, right? So please try to do this and tell me the value of lambda you are getting. Whether it is a non-degenerate conic or not. So do this and tell me the value of lambda. Find out that determinant delta should not be equal to 0. Alright, so I'm going to a live chat. And secondly, please let me know what is the value of lambda you are getting. That is h square minus ab should be equals to 0. So these are the conditions which represents a parabola. So this is a simple question, right? So please try to do this and tell me the value of lambda you are getting. So what is the value of lambda? So do this and tell me the value of lambda. Find out that determinant delta should not be equal to 0. Alright, so I'm going to a live chat. And secondly, please let me know what is the value of lambda you are getting. That is h square minus ab should be equals to 0. So these are the conditions which represents a parabola. So this is a simple question, right? So please try to do this and tell me the value of lambda you are getting. So if you solve it in order to find the value of lambda, that is, if you do this expression over here, that is h square minus ab equals to 0, in this case you will get lambda square to be coming out as 36, right? So from here I will have two values of lambda, that is plus or minus 6, right? But how to decide that which value of lambda actually satisfied it is basically depending on this particular expression, that is for which value of lambda I'm having it as a non-degenerate conic, right? So if you look into this, you will see that both the values of lambda, that is plus or minus 1, the delta is not equals to 0, right? So that basically forms that both of these values of lambda are correct, right? Is this part clear? Alright, so you must be getting the answer as plus or minus 6. Okay. Alright. Is this part clear to all of you? Is this part clear? Okay. So if you have any confusion, any doubts, please let me know in the live chat so that I can discuss about it. Or else we shall proceed with our discussion on the next topic, right? That is going to be the, let us now discuss about the properties of focal chord. Okay, let us now talk about the properties of focal chord. So if I talk about the properties of focal chord, now let us try to take the simple case of a parabola, that is y square is equal to 4ax, which is a standard simple parabola, right? So for this simple standard parabola, any point on this parabola can be taken as 80 square comma 2 times of 80, right? So for any standard parabola like this, any general point can be taken as 80 square comma 280, right? So therefore this is a standard equation parabola for which any point can be given like this, right? Where t is any parameter which is a real number, right? Now any line passing through the focus on the parabola is called a focal chord. So if I try to draw the parabola over here, this is my x and this is my y axis. So my parabola looks something like this. Now if I have the focus over here, which is a comma 0, so if I take up any point which is p and I draw a line passing through the focus something like this, and on the other side it is q, and this way we can say that this is basically the focal chord. So this is my focal chord, right? This is my x and this is my y axis. So my parabola looks something like this. Now let us say this p point is given in terms of parameter t1. like this, and this Q point is given in terms of parameter T2. Okay, so these are the two extremes of the focal chord. So P and Q are the two ends of the focal chord, right? And let us also say that the focal chord makes an angle theta with the positive x-axis, right? So if we have this, then the very first thing that we need to observe over here is that if I try to, if the chord joining P and Q is the focal chord, then what you will see that if you try to form the if you try to check the slope of the line, or if you try to see the collinearity condition of P, Q and S, then what you will obtain is that you will obtain some parameter like by collinearity condition. So that is the slope will be continuous for PS and SQ, right? So it is going to come something like this. So what I'm doing over here is that I'm just trying to satisfy the slope continuity, right? So slope of PS should be equal to slope of QS, right? So that is what I'm doing over here, because P, Q and S are collinear, right? So from the collinearity condition, there should be double L, right? Yes. So from collinearity condition, I'm trying to satisfy this. So if I do and solve this out, so if I do few lines of calculations over here, I'll get some expression like T1 into T2 square minus of 1 is equals to T2 into T1 square minus of 1, right? And if you simplify again further, we'll get T1 is equal to T1 minus T2, T1 minus T2, and times T1 T2 plus T2 minus T1 should be equals to 0, right? So now I can take T1 T2, T1 minus T2 as common, so T1 minus or T2 minus T1 as common. So then in this case I will have 1 minus T1 T2, right? Let me check. Oh, I have made a mistake. It should be T2 minus T1, T2 minus T1, and this should come as plus, and that should be equal to 0, right? Now since T1 and T2 are different, right? So T1 cannot be equal to T2. Therefore, the only way it is possible is this parameter becoming equals to, that is T1 T2 becoming equals to minus of 1. So therefore, for any focal chord, the important condition to remember is that T1 times T2 should be equals to minus of 1. So if my P point is given by this parameter T1, then this Q point is given by the parameter minus of 1 upon T1. So this T2 is equals to minus of 1 upon T1. I hope this is a very important condition and please keep it in mind. Okay, so whenever you will be discussing with questions of focal chord, you have to keep this part in mind, right? So these are one of the properties regarding the focal chord. I hope this is clear to all of you. Is this part clear? Now in a similar manner, if I want to try to find out the length of the focal chord, okay, so if I want to find out the length of the focal chord, if I try to find out the length of the focal chord PQ, so if I try to find out the length of the focal chord PQ, then this particular length, so PQ length is equals to PS plus QS, right? Now if you recall that we have been discussing that any distance of a point from focus is equals to the distance of that particular point from the, or perpendicular distance of the point from the directrix, right? So in this case our directrix is x plus a is equals to 0, so PS should be equals to PM, and similarly QS should be also equals to QN, right? So if I equate the PS plus QS is equals to PM plus QN, right? So this is also equals to PM plus Qn, because we know that the eccentricity of a parabola is equals to 1. So for this case, the focal distance is also equals to the distance of the point from the perpendicular distance of the point from the directrix, right? So in a similar manner, if I equate this, this is going to turn out as A times of T1. So this, if I try to talk about what is the distance of PM, that is going to turn out as A, and the distance of Qn, or this distance is going to be AT square plus A by T square, right? So this is how it would come out. So let us call it T1 because we have represented P as T1, right? So A plus AT square plus A upon T1 square, right? So that is how we will obtain the total distance, and this is going to come out as, so if I take A as common, it is going to come out as T plus 1 upon T whole square. So since we have written T1, so it's basically T1 over here, right? So this is the distance of the focal chord. So the focal chord distance is simply given out as A times T plus 1 upon T whole square of it, right? Is this part clear to all of you? Is this part clear? Okay. I assume this is clear to all of you. Okay, this is another very important property that whenever we'll be asking you the question of find out the length of the focal chord, then you can easily do it by applying this particular formula over here, right? Alright, so let us now move forward to the third property, that is that so the third property talks about that the length of the focal chord which makes an angle theta with the positive x-axis is 4a cosecant whole square theta, right? So that is what I will also get. So this PQ distance can also be given as, so since if I talk about the slope of this line PQ, this will come out as 2 upon T1 plus T2, right? And we have already seen that T1 plus T2 is basically reciprocal of each other, right? So negative times 1 upon, so T1 minus 1 upon T1, right? And if I simplify this part, this is going to come out as, so now we know that slope is given as tan theta is equals to 2 times of divided by t minus 1 upon t, right? So from here we can simplify it further and we can switch it as 2 times of cot theta is equals to t minus 1 upon t, right? So from here we can substitute, so we have already got the value of t minus 1 upon t, right? So therefore the PQ distance is going to be a times of t plus 1 upon t whole square, and that can be also written as a times now t minus 1 upon t this whole square. Why I'm doing this? Because I know the value of t minus 1 upon t, so I'm doing a modification. So t plus 1 upon t whole square can be written as t minus 1 upon t whole square plus of 4. Okay, plus of 4. Alright, so if I substitute the value over here, then I'm going to get the relation as a times of 4 cot square theta plus of 4, which can be simplified using the trigonometric identity, that is going to be 4 times of a cosecant square theta. Okay, so this is also going to be the length of the focal chord whose angle with the x-axis is known to us, right? So if I know the angle that the focal chord makes with the positive x-axis, in this manner also I can easily find out the length of the focal chord without even have to go into the details of finding out what is the parameter t, right? So I hope this is clear to all of you. I hope this is clear to all of you. Okay, so depending upon different types of question, we're also going to discuss about some more properties, right? So let us try to take some problems and try to understand that what are the things that we'll be trying to face, right? All right, so let us try to solve some few problems to start with, and let us start with a subjective problem. I hope this is clear to all of you. Okay, so depending upon different types of question, we're also going to discuss about some more properties, right? So let us say that we have been given with this problem over here, that if the length of the focal chord of the parabola, which is given the standard parabola, at a distance of at a distance b, okay, at a distance of b from the vertex is given as c, then prove that this particular relation holds true. Okay, so the length of the focal chord of this particular parabola is the question, right? So if I try to draw the parabola over here, I would like to I would like all of you to please try on it and tell me whether are you able to get to this expression or not, right? So this is how the standard parabola will look like, that is y square is equal to 4ax, right? And if I consider any point P, which is in terms of parameter at square comma 2at, and let us say this is my focal chord with s being the focus, which is a comma 0 and q with the other end of the focal chord, right? So this is going to be a comma t square minus 2a by t, right? This is the coordinate of point q, right? So if I have this form over here, then from this particular relation we have been given that the OM, so let us call the center the vertex as O and this point S. So this OS, which is mentioned over here, at a distance of B from the vertex is C, right? The length of the focal chord whose distance of the length of the focal chord of a parabola at a distance of b from the vertex. So this particular focal chord is at a distance of b from the vertex, which basically means this perpendicular distance. Okay, so this perpendicular distance is given as b. Okay, and then this length of the focal chord is given as C, right? So if I do this, so let us call this projection as M. So this OM is equals to B, and we know that the length of the focal chord having this, let us say this angle is theta, is basically given as 4A cosecant square of theta is basically the length of the focal chord PQ, right? Alright, now if I try to understand from this triangle, this right angle triangle OM and S, so this OM and S, this is a right angle triangle, this is length is B, and this particular angle is also going to be equal to theta because this is vertically opposite angle, right? So therefore sine of theta is equals to B upon A, is equals to B upon A because this particular length is going to be A, right? So sine of theta is equal to B upon A, so therefore cosec of theta is going to be A upon B, and if you put it over here, then the length of C is going to be equals to 4A times of A square by B square, right? So therefore I will obtain the relation that is B square C is equals to 4A cube. I hope this is clear to all of you. Okay, so this is how you can easily prove some of the important relation, right? So you can also keep this part in mind as well, right? How am I doing this question? So it's basically simple modification in the geometry which you can easily do it in order to get to this final answer. I hope this is clear to all of you. Is this part clear? Is this part clear? I hope this is clear to all of you. Okay, so this is how you can easily prove some of the important relation, right? So you can also keep this in mind as well, right? How am I doing this question? So it's basically simple modification in the geometry. I hope you are enjoying discussion on this kind of question. Okay, so maybe what I will do is that I can give you some more problems to practice. Okay, so some of the problems I would like all of you to practice, and we can discuss about the solutions in our later classes. Okay, so first of all, try to solve these problems. Okay, so take these problems as a homework problem. Okay, take a screenshot of these problems, and we'll discuss about the solution of this problem in some of the later classes. Okay, if you are having any question, or else we can proceed with the only the answers. Okay, so these are your homework problems. Okay, so these are your homework problems. So 5 problems for your homework. So please try to do it right after the class is over. Okay, because these are really important questions and good questions which you can try to see and understand this particular topic. Okay, please take a screenshot of this problem. Okay, and do let me know whatever answers you're getting. So right, these are your homework problems. Okay, so these are your homework problems. So is this part clear? So please try to do it. So in the next class, what we're going to do is that we're going to start with our discussion of what happens when you intersect a parabola with a given line, right? So in the next topic, we're going to learn about the intersection of a parabola with a line, right? Now, in which case the line becomes a tangent and which case the line becomes a normal. So all those discussion we are going to do in our next class. Okay, so I don't want to make this class quite an difficult class by discussion about the tangents and normal right itself, but let me take some time. So in the next lecture we're going to discuss about the tangents and normal, right? So these basic 3 classes basically are based upon building upon the very basic topics like especially the focal chord, the properties regarding the focal chord, and also we discussed about the standard equation of parabola and the general equation of parabola as well, right? So I am pretty sure that now from here itself that if you are given any general equation of conics, you will be able to recognize that what is the conics given to you, right? And depending on the conics that is given to you, you can take different action to it, right? So that is what the action of plan looks like. So we will have in our next class we'll start to discuss about tangents and normal, and you will see that the tangents and normal is again very similar to whatever you have studied in that case of circles, right? So again the similar properties of the similar expression is going to come like, right? The expression is going to different, but the expression like s1 equals 0 or t is equal to 0, all those things is going to remain the same, right? So all those transformation that we have learned in our previous topics of circles when we were discussing about tangents and normal, that is going to come over here as well, right? Is this part clear to all of you, right? So if you have any questions, you can let me know in the live chat, or else we can conclude the session over here. And I thank you for your attention in this particular lecture, and we hope to see you soon in our next class. Okay, so with this particular thing, I wish you all the best, and I hope to see you in our next topic where we will discuss about the tangents and normal, right? And along with that, we are going to start with very soon with our one-shot lectures. Okay, so stay tuned for that one-shot lectures, and with that particular one-shot lecture also we are going to devise the entire topics or entire syllabus of mathematics. Okay, and I thank you all for your wonderful attention, and I hope to see you soon in our next class. Thank you.